Hello viewers, I am Maithili. Today we are going to see 11 Cbse Maths Limits and Derivatives Miscellaneous Exercise question number 1. In that fourth subdivision we are going to see in this video. Let's see the question. Find the derivative from first principle cos x minus pi by 8. So cos x minus pi by 8 we are going to solve it using first principle formula. For that always take let f of x is equal to the given question, that is cos x minus pi by 8. Now we want the formula for the first principle, which is f dash x is equal to limit h tends to 0 f of x plus h minus f of x by h. This is the first principle formula. We are going to apply this formula. Here f dash x will become is equal to limit h tends to 0. Here in the x place we have x plus h, so substitute x plus h in the place of x. Here it becomes cos x plus h minus pi by 8. Instead of x we are going to substitute x plus h. Here that is minus pi by 8 minus, for f of x we have formula of they have given us cos x minus pi by 8 by total by h. Now if you see the numerator, it is in the form of cos something minus cos something. We have learnt in the trigonometric formula that cos a minus cos b, that is cos something minus cos something, is equal to minus 2 sin a plus b by 2 into sin a minus b by 2. Yeah, we are going to apply this formula here. F dash of x is equal to limit h tends to 0. Here minus 2 sine, if you be careful while writing, here we have cos a minus cos b. So a, while writing a, we need to write it completely. So a will become x plus h minus pi by 8 and b totally x minus pi by 8 divided by 2 into the same way sine. Here instead of a we have x plus h minus pi by 8. For b it is minus b, so we need to change the sign of both the things. So it becomes minus x plus pi by, if it is minus, write it as plus, if it is plus, write it as minus. Here this both get cancelled and here it get cancelled, divided by 2, the whole thing divided by h. Now solve it. Limit f dash x is equal to limit h tends to 0. Here it becomes minus 2. Here we have 2x. So 2x minus 2 pi by 8 plus h. Here we have sine only h by 2. The whole thing is divided by h. Now we can't apply the limit value here. Seeing this further we can't solve it, so we are planned to apply the limit value. But in the denominator, if we apply the limit value as it is 0, if we apply 0 here, the whole thing will become not defined, because the denominator is 0. So everything, the question, everything will become not defined. It should not be not defined, so we can't directly apply the limit value now. Further we need to solve it. Here we have a sine, here sine is a bigger theta, so leave it off. Here it is h by 2. If there is the denominator and the theta is value same, we have a formula that limit x tends to 0, sine x by x is equal to 1. We can only apply when the theta value and the denominator value is same. If the limit tends to 0, then the theta value with denominator value same, it becomes 1 for sine. Here we have h, but here we have h by 2, here we have h. If it is h by 2, then we can apply the limit value for this. For that reason, I am going to multiply the numerator and the denominator of h with 2. So as I want to limit h tends to 0, here it becomes minus 2 sine 2x minus 2 pi by 8 plus h into sine h by 2. I am going to multiply and divide by 2. Here this get cancelled. Now the denominator and the numerator has become same. So applying limit value, we have sign limit value h tends to 0. So here it becomes 2x plus 2x, sorry, minus 2 pi by 8. Yeah, instead of applying h value, it becomes 0. So leave it off into 1. While applying here, it becomes 1. We can take the, sorry, we have by 2 common. Take 2 common outside, it becomes sine 2 into x minus pi by 8 by 2. 2 get cancelled. Now your final answer is minus sine x minus pi by 8 is your final answer for the sum. That's all with the sum. Thank you.